Good day, everyone. We're diving into an exciting topic today. Story diffusion. Consistent self-attention for long-range image and video generation. This groundbreaking research tackles the challenge of generating subject-consistent images and videos for storytelling, a task that has stumped existing models. Our authors, Yuping Zhu, Daquan Zhu, Mingming Cheng, Jiaxi Feng, and Shibin Hao, introduce a novel method, consistent self-attention, that promises to revolutionize the way we generate and control visual content. Stay tuned for a deep dive into this fascinating work. Our research is driven by the goal to generate subject-consistent images and videos for storytelling. We observed that existing models, such as diffusion models, IP adapter, instant ID, and photomaker, face challenges in maintaining consistency in character identity and attire. This inconsistency poses a significant hurdle in creating a coherent narrative through images and videos. The problem we're addressing is multifaceted. Firstly, the strong guidance from existing methods tends to limit the controllability over text prompts. This means that the generated content may not align perfectly with the user's input. Secondly, these methods often fail to guarantee the consistency of attire and scenarios, which is crucial for storytelling. Lastly, the current solutions are computationally expensive and require a large amount of data, which is not always feasible. In light of these challenges, we're proposing a novel approach that aims to balance the need for consistency, controllability, and computational efficiency. Stay with us as we delve into the details of our proposed solution. Our research introduces two key highlights. Firstly, we present consistent self-attention, a novel method that replaces the original self-attention in the diffusion backbone. This approach incorporates sampled reference tokens from reference images during the calculation of the token similarity matrix and token merging. This innovative technique does not require additional training, making it a lightweight and efficient solution. Secondly, we focus on maintaining consistency in both identity and attire, which is crucial for storytelling. Our method generates highly consistent images that effectively narrate a story. By building connections among multiple images in a batch, we can ensure subject consistency, enhancing the overall storytelling experience. These advancements mark a significant step forward in the field of content generation. Our research is driven by the challenge of generating subject-consistent images and videos for storytelling. We noticed a significant issue in the field: a lack of consistency in character identity and attire across generated images and videos. To address this, we developed story diffusion, a novel approach that incorporates consistent self-attention into a pre-trained text-to-image diffusion model. This process involves splitting a story text into several prompts and generating images using these prompts in a batch. The result? Connections are built among multiple images, ensuring subject consistency. The figure here illustrates this pipeline, showing how we generate images that are consistent in terms of subject identity and attire. This is a significant step forward in the field of content generation, opening up new possibilities for storytelling. Our goal in this research is to maximize user controllability via text prompts while maintaining consistency in the generated content. This has significant potential to improve the quality of storytelling by generating high-quality images and videos that are consistent in character identity and attire. Previously, diffusion models, IP adapter, instant ID, and photomaker have been used to generate content. However, these methods have limitations in terms of controllability and consistency. Temporal modules, another common approach, are computationally expensive and require a large amount of data. To address these issues, we propose a new method: consistent self-attention. This method can be inserted into the diffusion backbone, replacing the original self-attention. It maintains consistency in character identity and attire across generated images and videos, opening up new possibilities for storytelling. Our research introduces key improvements to the field of content generation. We've developed a method that incorporates sampled reference tokens from reference images during the token similarity matrix calculation and token merging. This approach allows us to generate images that are consistent in terms of character identity and attire, which is crucial for storytelling. To generate a series of images that narrate a story, we divide the given story text into several prompts. Each prompt corresponds to an individual image, and our method generates these images in a batch. The result is a series of highly consistent images that effectively narrate the story. In addition to this, our method also supports the generation of longer stories. We've implemented consistent self-attention with a sliding window along the temporal dimension. This approach removes the dependency of peak memory consumption on the input text length, making it possible to generate longer stories. This is a significant step forward in the field of content generation, opening up new possibilities for storytelling. Our research introduces Storydiffusion, a groundbreaking method for generating subject-consistent images and videos. This method is built upon two key components: consistent self-attention and semantic motion predictor. Let's delve into the consistent self-attention. This is the heart of story diffusion. It replaces the original self-attention mechanism in the diffusion model. What makes it unique is its ability to incorporate reference tokens from images. This means it can draw on information from a reference image to guide the generation of a new image. The result? It builds connections among multiple images, ensuring consistency in the characters' identities and attires across different images. This is a crucial feature for storytelling, where maintaining character consistency is paramount. In essence, our consistent self-attention mechanism is a powerful tool that enables us to generate images that are not only high quality but also consistent in their content, all in a training-free manner. This is a significant step forward in the field of image and video generation. Our research introduces a novel process for generating subject-consistent images. We begin by dividing the story text into several prompts. Each prompt corresponds to an individual image, and we generate these images in a batch. To ensure consistency across these images, we build connections among them, focusing on maintaining the identity and attire of the characters. To support the generation of longer stories, we've implemented a technique called consistent self-attention with a sliding window. This approach effectively removes the dependency of peak memory consumption on the length of the input text, making it possible to generate longer narratives without compromising computational efficiency. Now, let's talk about the transition from static images to dynamic videos. We've developed a semantic motion predictor that predicts transitions between images. This tool not only generates stable results, but also handles larger movements, enhancing the realism and fluidity of the generated videos. Finally, we use the semantic motion predictor to transition the generated images into videos. This step significantly improves the narration and overall quality of the content, providing a seamless and engaging storytelling experience. This combination of techniques allows us to generate high-quality, subject-consistent images and videos that effectively narrate a story. Story diffusion, our proposed method, excels in generating images that maintain consistency in character identity and attire. This consistency is crucial in effectively narrating a story through images. But we didn't stop there. To transition these images into videos, we introduced the Semantic Motion Predictor. This tool enhances the quality of video generation, providing a seamless transition between images. Moreover, story diffusion demonstrates robustness in handling larger movements. This is a significant improvement over previous methods, which often struggled with complex transitions. Our method, therefore, not only ensures consistency in image generation, but also enhances the quality and robustness of video generation. This combination of features makes story diffusion a powerful tool for storytelling through visual content. As we draw to a close, let's take a moment to appreciate the images and videos generated by story diffusion, displayed on the left. These examples showcase the method's ability to generate highly consistent images that effectively narrate a story and handle larger movements. This is a testament to the power of our approach in creating engaging and coherent visual narratives. Now, let's revisit the key contributions of our work. Firstly, we introduce story diffusion, a novel method for generating subject-consistent images and videos. This approach allows us to create visual content that is not only high quality, but also maintains consistency in character identity and attire, a crucial aspect for storytelling. Secondly, we developed consistent self-attention, a core component of story diffusion. This technique builds connections among multiple images in a batch, ensuring subject consistency across the generated images. It's a lightweight method that requires minimal data and computational cost, making it a practical solution for many applications. Lastly, we proposed the Semantic Motion Predictor. This tool predicts transitions between images in the semantic spaces, providing more stable results than predictions in the image latent spaces. This innovation allows us to create smooth and coherent transitions in our generated videos, enhancing the overall storytelling experience. In conclusion, our work presents significant advancements in the field of content generation, paving the way for more engaging and consistent visual narratives.